We are now going to review our third and final portion of Concept 36, which is special right triangles, specifically 30, 60, 90 triangles. So the rules are very similar to 45, 45, 90 triangles, but there's a few little differences. But they essentially work the same way. Now these triangles are not isosceles triangles, so we don't have any equal sides. But when we do have them, there's a certain way for us to label the sides to make everything more simple. So we have the shorter leg, the longer leg, and the hypotenuse. The hypotenuse hasn't changed. That's still the diagonal, right? Across from the right angle. So hypotenuse is always the diagonal, and then the two legs make up the right angle. But there's always going to be a short leg, which is here, short leg, and this is a longer leg. And the easiest way to tell is if you look at your 30-degree angle and draw a line, or like an arrow going across from the 30-degree angle, that side is your shortest side. And this kind of makes sense, right? Like the smallest angle goes to the smallest side, and the medium angle goes to the medium side, or the long side in this case, and the 90-degree angle, the biggest angle, goes to our hypotenuse, which is our longest side. So if we were to label our shorter leg x, like whatever our shorter leg is, if we gave it the variable x, we actually find that in 30, 60, 90 triangles, the hypotenuse is always twice of that short side. So the short leg is x, the hypotenuse will be 2x. And then to find the longer leg, we would take the short leg and multiply it this time by the square root of 3. So if we know one side, we can find the other sides. That's the beauty of it, right? You know, with the Pythagorean theorem, if we would have to know two sides to find the third side. But with these triangles, if we only know one, we can find all three. So just some equations as to how to go about doing this. Again, the hypotenuse is twice the short leg, okay? Hypotenuse is twice the short leg. And if I wanted to calculate the short leg and I know the hypotenuse, I can divide the hypotenuse by 2. If I find half of the hypotenuse, I'll get my short leg. And then if I know my long leg, or if I'm trying to find my long leg and I know my short leg, again, I would multiply by the square root of 3. And on the flip side, if I wanted to find my short leg and I knew my long leg, I would take the long leg and divide it by the square root of 3. So that's really helpful because, you know, if we know one piece, again, we can find all the other pieces. So let's put this into practice. So if I want to find, I have a 30, 60, 90 triangle here. This is my 30-degree angle. I know that my short side is 7. And my hypotenuse would be y. Well, I know that my hypotenuse is twice my leg, my short leg. So if my short leg is 7, my hypotenuse is 14. I'll just label that the hypotenuse. And my longer leg, x, would be 7, which is my short leg, times the square root of 3. And that's what those sides would be. We don't need to simplify any further. That's it. We found all the sides. Let's try it again, but this time we start with the hypotenuse. So if I know the hypotenuse, I want to find my short leg. So my short leg is half of my hypotenuse. I would do 20 over 2 to get 10. So my short leg is 10. And I know that my long leg is my short leg times the square root of 3. That's it. No crazy calculations. I don't have to do the Pythagorean theorem. Even though if you did, it would work. We don't get any crazy decimals or anything. This is it. So here's where we're going to introduce some radicals. So I need to find x and y. First off, to find y, I need to double my short leg, right? So 4 square root 2 times 2 is just 8 square root 2. Remember, I can only multiply the terms if they're both outside of the square root or they're both inside the square root. So I would multiply 4 times 2 to get 8. I would leave my square root the same. And if I wanted to find my x, I would take my 4 square root 2 and multiply it by the square root of 3. And then in this case, I would multiply what's inside the square roots. So this would be 4 square root 6. And I can't simplify them any further, so I just leave it like that. So in example 4, we kind of have a similar case, but now we're starting with my hypotenuse. So to find x, I need to take my 8 square root 6 and divide it by 2. So that gives me 4 square root 6. Nothing crazy there. Now my y would be my x, which is 4 square root 6. And I'm going to multiply it by the square root of 3 because that's my rule. So here I would get 4 square root of 18. Now, if you recall, the square root of 18 can be simplified into the square root of 9 times 2, which can then be simplified into 3 square root 2, because the square root of 9 is 3. So then we would take 4 and multiply it not by the square root of 18, but by 3 square root 2. And then we would simplify 4 times 3 is 12 times the square root of 2. So that's my x, and that is my y. I know it gets a little tricky, but it's just combining what we did in the previous lessons to simplify our answer. Here's where it gets, again, a little complicated. To find x, I need to take my long side, 9 square root 2, and divide it by the square root of 3. Now, if you watched part 1, we know that we need to rationalize the denominator. So I'm going to multiply both sides by the square root of 3, or the top and the bottom by the square root of 3. So we have 9 square root 6 over 3. And of course, 9 divided by 3 is just 3. So I have 3 square root 6. So that's my x. And I know that my y is twice my x, because my y is my hypotenuse. So I need to take 3 square root 6 and multiply it by 2. Again, I'm multiplying the terms that are outside the square root. So 3 times 2 becomes 6, and then I have the square root of 6. So there's my y, there's my x. Example 6. I'll change the color here. I know my long side, so I want to find my short side. So my long side divided by the square root of 3. Again, we are going to rationalize the denominator. So I get 12 square root 3 over 3, and then this simplifies to 4 square root of 3. So that's my y. And then I know that my x, which is my hypotenuse, is just double of my short side, which in this case is y. So we would take 4 square root of 3 times 2, and it would be 8 square root 3. So my x is there, my y is there. Here is a problem that looks kind of crazy because we have a combination of a 45, 45, 90 triangle on the left and a 30, 60, 90 triangle on the right. So we're sort of combining the things we did in part 2 with what we're doing here in part 3. But luckily, this is actually fairly straightforward. So if I take a look at just the right side for a second, or the left side for a second, I can find out a few things. I know that A and B are going to be the same because they are, it's a 45, 45, 90 triangle. Well, if you recall, I need to take my hypotenuse and divide it by the square root of 2, and the square root of 2's cancel each other out. So A and B are 5. A equals 5 and B equals 5. 2 down, 2 to go. Well, cool thing is, since I know B is the short side of my 30, 60, 90 triangle. So now to find C, I would double it. So C should be 10, and D should be my short side times the square root of 3. So I would say 5 times the square root of 3. So it looked crazy, but like, if we follow the rules, we know exactly, we're given exactly what we need. Here I have another combination problem. So let's tackle this. I know the hypotenuse of my 30, 60, 90 triangle is 12, so I know my short side, x, is going to be 6. And I know my, so in this 45, 45, 90 triangle, I have a y and a z. But since I know that the legs are the same, I know that this must be y as well. But y happens to be the long side of my 30, 60, 90 triangle. And I know that my long side of my 30, 60, 90 triangle is my short side times the square root of 3. So now we know y. To find z of my 45, 45, 90 triangle is I need to take my my leg, which in this case is 6 square root 3, and multiply it by the square root of 2. So it becomes 6 square root of 6. I hope you all had fun. I know I did. I really enjoyed this lesson. And that's our 30, 60, 90 triangles, and that concludes concept 36.